So now let's see some examples of integration by parts. So here I have some integrals that I can use the method of integration by parts, and you're gonna see how we use that to simplify to an integral where we can integrate much more easier. The first example is gonna be this integral from integral of e to the x times x squared. And as you can see, this is the multiplication of two functions is much more clear. That's not always going to be the case. But in here, I can kind of start by saying, well, let me pick who's going to be u and who's going to be dv. Okay? And u should be the function that is easy to take derivative, and dv should be the function that is easier to integrate. That can be sometimes difficult to decide, but then the second level of complexity that you should take is that dv should be a less complex function than what you can have in here. Okay, so what's going to happen is that I'm going to pick initially u to be x squared, and see how that works. Because immediately notice that the u dx is going to be 2x. So that means that the u is going to be 2x dx. dv is e to the x, and that's fine because immediately you can see that the integral of dv, which will be the integral of e to the x dx, would be just e to the x as well, plus a constant, but we're not going to use the constant here. Now, if we use the formula by integration by part, remember this is u times b minus the integral of b du. And so that will produce u, which is x squared, times e to the x, minus the integral of b du. And b is x, and du is 2x. So we're going to get 2x e to the x. Did we accomplish what we wanted? Yes, we accomplished what we wanted because we're simplifying. Notice that this was x squared, and now we're reducing the power here to be just a single x power to the x. We actually can now repeat the procedure to simplify this integration. Notice that I can do now u equals x, dv can be again e to the x. And so now the u is going to be 1, and b is e to the x again. So we can take this integral here, and I can express that as x e to the x minus the integral of b du, which will be e to the x d1. And this has a dx here, right? And so this is much more easier to manage. This is now x e to the x minus the integral of e to the x, which is e to the x. And so e to the x plus c. And so last but not least, this means that this integral here, let me just remove this here. This integral here of e to the x, x squared dx can become x squared e to the x minus, and then I'm going to put this here, x e to the x minus e to the x, and then everything plus c outside. The sign doesn't matter for the plus c. Okay. Notice that at the end, this will be the end of this integration. I can break apart this minus if you want to. This is x squared e to the x minus x e to the x plus e to the x plus c. Okay. Sometimes you don't have an evident use of the integration by part, like for example in this function here, log of x. But the problem is that you don't have another method of integration that you can use for this. So that's why we use integration by part, because we're kind of trading the function here by the derivative. So we use u is equals ln of x, And if I don't have a second function, then that means that our dv is just going to be 1 dx. Our function g prime, or the dv, is going to include the 1. So now if I integrate 1, of course I get x. Integrating 1 dx, I get x. And doing the derivative du, I'm going to get 1 over x dx, right? Which is the derivative. The derivative of log of x is 1 over x. And so du dx is 1 over x. And so du is 1 over x dx. Now, doing the integration by parts, this is u times b minus the integral of b times u. Notice what happens. The u times b, it becomes x log of x minus b. And so b is x. And then the u is 1 over x dx. And so this becomes x log of x minus the integral of 1. And so this is going to be x log of x minus x plus c. And that helps me transition the integral of log of x, which was something that we did not have before. Now let's actually use this x log of x now, but we're gonna integrate this. So this is a much more clear multiplication of functions. We're gonna try to do the same thing. I always want to reduce power, so if I get this type of power, u is equals x, and then dv is going to be log of x dx. Normally in another situation that'll be bad, having the log of x dx here situation, but here's not going to be the case. So the u dx is 1, so the u is 1 dx, and b is the integral of log of x dx. But we just saw what the integral of that was, which is x log of x minus x. So we're kind of cheating a little bit because we just saw this one here. Otherwise, this will require a double integration by parts. But anyway, so using the formula then we have u times b minus b du. And so we can say, oh, okay, so u is x, and then b is going to be this x log of x minus x, and then minus, and then b du. And so notice what's going to happen here. We get x log of x minus x, and then the du is 1 dx, so we get this. So this is a failure of integration by parts, because we are having this integral, and the integral that we get here is much more complicated than what we get in there. Okay, and so the first thing that we gotta see is, can we solve this out somehow? And if we cannot, then we can change our integration route. In this case, though, we're going to be able to fix it using a formulaic approach. Notice that I can break this apart as x. This is going to be x squared log of x minus x squared. And I can see this one as minus x log of x. And then this minus with this minus is plus. And so the integral of x dx. Okay? But notice that this integral is exactly the same as the original that we have. So we're going to move this to the other side. And so now we're going to have that 2x log of x dx is going to be x squared minus x squared log of x minus x squared. And this one is going to provide me x squared divided by 2 plus c. And so we're kind of solving the integration. But we fortunately were able to just move this part here. If we get something much more complicated that we cannot deal in this way, then we're going to have to look for another approach to the integration. So now this will be the integral of x log of x would be We're going to divide by 2, but we're going to simplify this first. Notice that this is 1/2 minus 1, so we're going to get minus 1/2. And so we're going to get x squared log of x minus 1/2 of x squared. And then we're going to divide by this 2, and then plus c. And that'll be the end of this particular example. Now, sometimes that approach that we just use gotta be used in an iterative way. In this example of e to the x sine of x dx can be one of those scenarios. So first, let's consider what are the substitutions that we can use. So again, b is e to the x. I can use that one because it's very easy to integrate. So dv is this, and so b will be e to the x again. Will be the integration of this. And I can use u equals sine of x, and so the u becomes cosine of x dx. Now, using the formula, this integral here will be e to the x sine of x is u times b, which is e to the x sine of x, minus the integral of b du. But b is e to the x, and du is cosine of x dx. So notice that we didn't accomplish much. We changed e to the x sine of x by e to the x cosine of x. So are we really doing something so far? Not really. We're going to have to do, again, integration by parts here. And so we're going to follow the same pattern. U is cosine of x. And so du is going to be minus sine of x dx. And so dv, again, e to the x. And so b is e to the x. But now notice what's going to happen. So here, I'm going to have this e to the x sine of x. Actually, let me write this here. E to the x sine of x is equals to e to the x sine of x minus, and then we're going to have u times b, so e to the x times cosine of x minus b du, so e to the x, and then du is minus sine of x dx, so plus with that minus, and I get this one. Now notice that I reach the same integral again, e to the x sine of x, and I have e to the x sine of x here. So fortunately we have this minus multiplying, and that means that I'm going to be able to move it to this side. So I'm going to have twice e to the x sine of x dx, because I'm taking this one with the minus, and so minus to the other side gets to be plus. Okay, and this side becomes e to the sine of x minus e to the x cosine of x. Okay. So again, this is another of those scenarios where we obtain the final value of the formula after doing iteration of the integration by parts. And the e to the x sine of x dx becomes e to the x sine of x minus e to the x cosine of x divided by 2. All right. And this is the end of the examples for 7.1. Make sure to check more examples on the weekly practice videos.